salmon shirt. Would that have worked? I don't know. You know what salmon color? Darn it. I should have wore it because I do like that shirt. It's anyone ever see The Big Lebowski? I guarantee you haven't. Have you really? Have you really? Oh my gosh. Tell your dad I'm going to be Walter Sobchak for Halloween. I'm not kidding. Maybe I'll take a picture of myself, give it, and then send it to you. Then you could show my dad. But I have a Walter Sobchak shirt, calmer than you are. Remember that line? Calmer than you are. And then but it's all salmon. I'm glad this is on the movie. All right. Okay. So there we go. I just told the students that we really should find the domain and range. And with the restricted domain, then the domain is restricted when we, state that. And then it affects the domain and range of the new. And then we'll go through that in the next one and cover that. By the way, I'm not doing this on these other ones, but these domain and range of lines is all real numbers, unless it's vertical or horizontal, right? Vertical line is not a function, first of all. Horizontal line and range is just one number, so that's a unique scenario. But when we get into these, then we got some issues. We got a lot of review going on in here today. I love this lesson, reviewing some graphing things. I think we mentioned it yesterday, but for this one it doesn't apply. I can kind of consider this parabola in vertex form. I can't believe someone in class knows The Big Lebowski. That's amazing. Your dad's a great guy. I should call him just today, just for the heck of it. Alrighty then. Input, say it. What do you think I should input first? What number? 3, 2, 1, go. Not 3, 0. I want to find the vertex value. This isn't moved right or left at all. It's just moved down 9. That's why I kind of consider this vertex form. Nice little review from chapter 3, I believe. Can't remember my chapters because I think chapter 4, not this chapter 4, the other chapter 4. So confusing. I hate not having a book. Was solving. 3 was graphing. And what I want to do is plug in 0. 0 squared is 0. 0 minus 9 is negative 9. Trying to have my eyes see that. Then the pen doesn't work. That's nice. Okay, so I got that all the way down there. And then technically back in chapter 3, we plugged in 1, negative 1, negative 2, 2. And I'm going to go ahead and do that right now, but then undo something. All right, negative 1 squared is 1. 1 minus 9 is negative 8. So shall 1 be negative 8. Oh, come on. Oh, my gosh. Do you see this little blips going on here? Okay, anyway. And then 2 squared is 4. 4 minus 9 is negative 5. I want to make sure I did that one more time. 2 squared is 4. 4 minus 9. And then 0 was negative 9. And sorry for this being kind of squeezed out of there. All right, but then here's the problem. Negative 8. And then negative 5. Right? Wasn't it 2, negative 5? Right? Okay. Here's the problem. If I graph this, oh gosh, let me start that over. Whew, it's a very slippery screen. Actually, I found that writing on the slippery screen for 9 months, now I have problems like writing my name on a piece of paper. Like my hand's very slippery. It's really affected my writing. I should sue the school. All right, anyway. Is this function 1 to 1? Yes or no, everybody? Blah, blah, blah. Yes or no? 3, 2, 1, go. No, I saw some people say yes. No, this is a failure of the horizontal line test. 1-to-1 functions have no repeating y's. So this is what I need to decide. I need to restrict the domain because mathematicians love functions. We don't like non-functions. So I want the inverse to be a function. So I make a choice, and you do actually literally have a choice. You have a choice to eliminate this part of the graph or this one. It's either or. I almost always choose the positive side. So I am going to eliminate this part of the graph and these points. Therefore, I have made a choice on how I'm going to restrict the domain. So these are outs. I don't want those. All right. And therefore, my restricted domain is this. And I'm going to write this up here. From 0 to infinity, just like the last one. All right, and that just happened because that's where the vertex is. Therefore, the range, actually the range isn't affected by this. The range is, you should be able to tell me, -9 to infinity. Before I find the inverse, I'm going to find the domain and range of the inverse. And I'm going to use colors for that. So this really matters now. The domain of the inverse is equal to the range of the original. And then I'll show you how this affects what this, with our inverse equation, what we have to do. And the range of the inverse is the domain of the original. Okay, so that has to be considered. Domain and range exchange or switch X and Y, for sure that's the case. Now I'll get into the finding the inverse. And I hope we're getting this, that this is Y. So we should be able to jump to this being X right away. And this is Y. X turns into Y. So switch X and Y. Then I could zoom in on the solving of this. Add 9, just for speeding things up. And then square root. Whoa. You calm down, Mr. S. And then now we get some review. I am going to write this, though, because mathematically this is sound. It is a plus minus that I put in front of this. But then I look at my range and what it's supposed to be. My range can only be, because it came from this restricted domain, positive. So therefore, and I should have said that on the previous one, this is why I scratched out that negative output thing there. The minus of the plus minus. The actual inverse of this is only the positive chunk. Sorry, I forgot something there. Negative first. And then it's only the square roots of x plus 9. And then this is where I get sad. And I know I pick on my cat students all the time, but we just had chapter 1 where they had to graph 7 or 8 different functions by input-output. And the pictures I got just absolutely made no sense whatsoever because they apparently cannot evaluate. So what do I plug in first, folks? Be careful. 3, 2, 1, go. Not 0. Let's start over. What do I plug in first? 3, 2, 1, go. I heard a few people say -9. You got to plug in a number that makes it 0 on the inside. All right, that's the starting point of what is allowed for this function anyway. -9 plus 9 is 0. Square root of 0 is 0. All right, so the inability to do these simple calculations is really worrying me. It really is, as far as being able to input-output. Well, the only thing I say is you just either got to figure it out or you're going to continue to struggle. And I'm not writing these evaluations down. We got to be able to do that in this higher level math class. Next one is -8. I'll plug in 0 later, but it's not the starting point. You got to get. Can I plug in -10? And that needs to be gone over again. Can I plug in -10? Yes or no? 3, 2, 1, go. No. -10 plus 9 is a negative. Square root of a negative is an I number. And that doesn't graph on a coordinate plane that's real. Let's just put it that way. But -8 plus 9 is 1. Square root of 1 is 1. And I told you 3 points. Fine. 0 is okay, but it's not the starting point. What's 0 plus 9? 9. What's the square root of 9, everybody? 3. So it's 1, 2, 3. Okay. So this is what I get. And I should have kept going with this graph. And then I hope I didn't cheat there, but these are reflections over the y equals x line, and we could see that. Or when I say inverse, you say, switch x and y. This is 0, comma, -9, sorry. This is -9, 0, switch x and y. So on and so forth. These 2 points here are reflections of each other, switching x and y. So on and so on and so forth. So the destruction of the negative on that plus minus, it's because of where this came from. All right. And then I think we said this verbally. That's how we say everything, verbally. How do I find the vertex of this? I'll start you off. -3, 2, 1, go. B over 2a. Again, this is why I love this as review. Things that you're supposed to be able to carry over if they show up again. And this is why you got to get there. Okay, so it's -b over 2a. And that's our x-coordinate of the vertex. Understanding that it's at the vertex where we have the change of direction. So therefore, that's the most important point to consider, as far as restricting the domain. And then if you're a good factorer, by the way, you'd be a good foiler, you might be able to figure out what happens when I plug in -4. By the way, what multiplies to 16 and adds to 8? Just want to ask that question. 3, 2, 1, go. 4 and 4. This is actually x plus 4 times x plus 4, which is x plus 4 squared. This means the vertex is right on the x-axis. But I'll prove it. -4 squared is 16 plus 8 times -4, which is, by the way, input, say it. This is how you get the y-coordinate of the vertex. -32 and then 16. 16 plus 16 minus 32 is 0. So the vertex is -4, 0. And I'm going to go ahead and plot that. Then what I did with my class was I inputted a couple other things. But here's the thing now. This tells me where I restrict the domain. At -4, then before and after it, that's where I'll have the parabola going up, like this. And I don't know if you can see me doing that on the screen here. But I want this to be 1 to 1. So at this point, I make a choice. Do I plug in to the right or to the left? Your choice. I like always going right. I think it's because I'm right-handed. I don't know. Or usually people pick the more positive side of things. So the domain for this has already been established. I am going to graph this from -4 to infinity, or I could go from -infinity to -4. I could choose the left or the right of the vertex. All right, and then I'll wait on the range here for a second, because now I have to plug in -3. If you know anything about this will end up being, I think, 1. -3 squared is 9. 9 plus 16 is 25. This is -24. So I plugged in -3 and I got 1. And then one more maybe, -2 squared. Kind of going fast on the evaluation because this isn't something I feel like I should have to teach how to calculate numbers. It really isn't. It really shouldn't be. -16 plus 16 is 0, and then that leaves me 4. All right, so I plugged in -2 and I got 4. So there's my restricted domain, half of a parabola. A little shaky there. Okay, so now I can look at the range. I actually probably could have figured this out before, but this range is from 0 to infinity. All right, now that I look at this picture. So the original domain and range, going to leak out of here, 0 to infinity. Before I find the inverse, I'm going to state what the domain and range is. Dang it. That's a brain mishap. Domain is the range of the original. Range is the domain of the original. Now, we got lucky and Mrs. Fasola created this problem on purpose. Because to find the inverse of this, you may get a little scared. But remember what I asked you about what multiplies to 16 and adds to 8. It's going to save us. Mrs. Fasola actually did teach her kids completing the square during the solving portion of the old chapter 4, solving quadratics. We did not. I'm waiting for another chapter, which I believe is going to be our next chapter, where it really comes into play, the completing square. You have no idea what I'm talking about right now, and I know that. But luckily, when I switched X and Y, and by the way, switch both of these X's to Y's, luckily, this is a perfect square trinomial. Yet again, what multiplies to 16 and adds to 8? 3, 2, 1, go. 4. In the process of completing the square that you don't even know about, unless you've been in something like, maybe if you're a math team or whatever, this is what ends up happening. You make this happen. You make a trinomial be a perfect square so that you can factor it. So I just want you to know that, and it is coming up. And this ends up being y plus 4 times y plus 4, which is y plus 4 squared. So in the process of this completing a square you've never heard of, you end up at a step like this. You really do. And then the next thing you have to do is factor that perfect square trinomial. Because now, how am I going to solve for y? How do you undo squares? 3, 2, 1, go. Square root. Okay, so I do want you to hear that term and know that this is part of that process. All right, and then when we get to it in a later chapter, then we'll have a better understanding. Guess what I'm going to do again? Plus, minus, because mathematically that's what happens. But I chose to have a range. Now you're going to see the minus 4. That is not all real numbers. It's limited to only half of that parabola. And I chose the positive on the domain of the original. So this is only the positive that I choose here. If you chose a domain that was negative infinity to negative 4, you'd cross off the plus and choose the minus. And that's what's complicated. That's another reason why I choose right all the time. Because I know I just lop off the minus and the plus minus. So I'll say that one more time. If you made the choice to graph this half, this one right here, then you'd have to choose the negative and get rid of the positive. Right? And that's why I don't do that. That's another reason. All right, but by the way, you subtract 4, and then you call this the inverse. And only choose the positive, and then it's minus 4. And then what do you input for this to graph? What's the first point I should input? 3, 2, 1, go. 0. What's the square root of 0? 0. 0 minus 4 is negative 4. Okay, 0 comma negative 4. Oh, negative 4, 0. Domain and range exchange. You guys okay back there? And then 1. Square root of 1 is 1. 1 minus 4 is negative 3. You still okay? So 1, negative 3. Now don't just do this. I get clowns that do this. 2 points. And then they just draw, oh, it's a parabola. Wrong. Do one more point. I know that, writing it down. Square root of 4. Maybe, yeah, we're only up to 4 here. So square root of 4 is 2. 2 minus 4 is negative 2. So 4, negative 2, this is what a square root looks like. And then I could draw the y equals line and see that is a reflection over the y equals x line. I didn't finish y equals x line. All right. Okay. Not exciting stuff, but it is what you got to do. I cannot overemphasize find the domain and range of the original before you actually find the, or find the domain and range of the inverse before you find the inverse. All right. And then parabola is going on there. Okay, next. So do I have to restrict the domain? It's really the same set of directions. And then looking at this, do I have to restrict the domain? Well, first we should graph this. What should I input first, everybody? 3, 2, 1, go. 2. If you're still not doing that, that's how I feel about you. You're so far behind, I should just throw you out in the rain in the middle of that field out there. I mean, I'm done with this. Done. 2 minus 2 is 0. Square root of 0 is 0. So, yeah. Okay. So, 2, comma 0. And then the next thing I should plug in is 0. Wrong. 0 is a square root of a negative. I have to plug in 3. 3 minus 2 is 1. Square root of 1 is 1. So, 3, comma 1. And then maybe the next one is 6. 6 minus 2 is 4. Square root of 4 is 2. So here's that same classic square root looking graph. Get it figured out. It's input output. It makes me intensely worried that we can't get these pictures. It is really a grade school concept. All right, but I think those graphic calculators, there's reasons. There's something going on, and I don't know what it is, but first of all, function. Second of all, isn't this function already 1-to-1? Yes or no? 3, 2, 1, go. No restricted domain needed. I'm actually physically going to write that for you. Uh-oh, I must have destroyed my computer there. No domain restriction needed. Okay, so we can proceed on. But before I proceed on, what is the domain? And it is 2 to infinity. What is the range? It is 0 to infinity. Before I find the inverse, the domain should be 0 to infinity. Now that's a restriction. Watch what happens when I find the inverse and how I'm able to graph this. The range is 2 to infinity. Domain and range exchange. Switch X and Y. Okay, so we should know that this is Y. So now it is X. And then we should know that this is Y on the inside. Now squeeze the rest of this work in this little tunnel that I have in between these two questions here. Okay, how do I get rid of a square root? You square. I shouldn't have to bother anyone on this. You should know these things. This is a free y minus 2. This is x squared. Wait a minute. X squared is a full parabola. You know, a full parabola like this. That's why we have to consider what the domain and range is. Sorry, saving of space. Call that inverse of f of x. Hopefully I did that on the last one. I don't know if I did. I'm not going back though. Should rename it the inverse of f of x equals x squared plus 2. But I can only graph this graph with a chart of values from 0 to infinity. So there's the thing. I can't draw the full parabola if I ask you to graph the inverse as well. I can only graph it under the conditions of where this came from. And it came from something that had a limited domain and range. All right, so therefore we must have a limited domain in this case. Just the domain's limited. The range does kind of have the same thing. But anyway, I can plug in 0 and I get 2. I can plug in 1 and I get 3. I shouldn't have to explain that. It's very simple to calculate. 1 squared is 1. 2 squared is 4. 4 plus 2 is 6. And then there's that half, and that's the only half I can graph. And then, of course, y equals x line, I only graph this part of it. There is definitely symmetry there. Okay? All right, got to move on. Should be good to go. Boom, boom. This is the review again of how many people awfully could not graph a cube root. Input, say it. That's why I'm scared. We can't calculate. Very scared. Okay, what's the first number I should plug in for x? 3, 2, 1, go. Not 2, 0. I want the point that makes it 0 on the inside for a cube root. That's called the point of inflection. And we'll see that in this picture. By the way, 0 plugged in, I get 0. I'm not explaining how that happens. High-level math class. What did you say next, though? 3, 2, 1, go. 2. Okay, so 2 is good because 2 times 4 is 8. The cube root of 8 is 2, but negative. So I plugged in 2. I got negative 2. Careful. I'm also going to plug in negative 2. What's negative 2 times 4? Negative 8. What's the cube root of negative 8? 3, 2, 1, go. Negative 2. I only had a couple people tell me that. Negative 2 times negative 2 times negative 2 is negative 2. Or negative 8. I'm sorry, I screwed that up. So I plug in negative 2. I get negative 2, but then it's negative. So now it's positive 2. So I plugged in negative 2 and I got positive 2. Now hold on. Some people were able to calculate this, and then this is what they did after this. And then they just did a graph like that. Now I wanted to throw up on your paper. All right? I did not like that whatsoever. So then, what's the next point? Let's see if anyone can figure out the next good point that you could plug in. Raise your hand if you know a next good point that actually calculates. I'll tell you what I tried to accomplish. The next perfect cube is 27. Isn't it hard to think 4 times 1 equals 27, right? What's the next perfect cube? And then think about what number I should plug in for x. We'll try you first. 16. Is that what you're going to say? Just say yes. 16 is correct, because if I plug in 16 for x, what's 4 times 16, everybody? Oh, I don't know if this is going to go well. 3, 2, 1, go. 64. Good, I did hear a lot of people. So 16 comma. You know where 16 is? It's way out here, and I'm actually going to graph it. 16 times 4 is 64. Cube of 64 is 4. Negative. 16 comma 5, 10. Let's get this. 5, 10, 15, about 16 comma negative 4 is like way out here. And it's just to prove the point that this graph goes like this and flattens out immensely like that. And it's a nice, smooth curve. It's not a bunch of wiggling in the middle that I got some of you to do. Some people put some real crazy pictures after this. And then that flattens out like that. So it's nice and smooth. And it goes, it doesn't really increase and decrease too quickly. It's really flat there. It's the best way I can explain this. So again, nice little review for those that destroyed the graphing portion, of this. So what you're going to come to find out is the domain and range is all real numbers. You can cube root a negative. Stop writing I when you're evaluating cube roots. It never, ever, ever happens. Never. Okay, so before I continue, then there's really no restrictions going on here. When I domain and range exchange, there is nothing special going on here. And then I can go ahead and do my inverse work now. So the green is the inverses domain and range. Okay, so f of x is y, so I make it x. Negative and then cube root 4y. Now, what I think you should do is multiply both sides by a negative first. So I went ahead and did that. And then cube both sides. Don't be doing anything with that 4 yet. It's stuck in the cube root. You got to free it before you do something with that. That's other things that goofballs are doing when we do our math operations. That's not a math 2 thing. That's what you came in with. Those general algebra skills. And then when I divide by 4, I guess another way we could look at it is 1/4 negative x cubed. Okay? And then that's our inverse. Okay, so now for the first time in forever, you're going to graph a cube. We are actually going to do cubes and Cortex and x to the 5th graphs in April and May. All right, that's what we plan, I think, on ending the year with. It's a really good end, really good algebra stuff. Input, say it. You still can graph it. 0 for x, 0 for y. Okay? And then you still can graph. You know what I am going to plug in? I'm going to plug in 2. Because I look at this point here. This is interesting. 2 cubed is 8. 1/4 of 8 is 2. Negative. So I plugged in 2. I got negative 2. What? That's right on top of the red graph. This is crazy. And then it disappeared because it went behind it. Negative 2 cubed is negative 8. 1/4 of negative 8 is negative 2. Negative. That makes it positive 2. So I plugged in negative 2 and I got positive. What? Those are right on top of each other. Is this the exact same graph? Heck no. You know what I'm going to do? I'm going to cheat. You see this point? This was 16 comma negative 4. So guess what happens when I plug in negative 4 for x? What do you think I'm going to get? Domain and range exchange. Everyone should have answered that right away. 3, 2, 1, go. 16. So at negative 4, I get 16, which is way up here, which means this graph actually looks like this. Come on, pen. And then takes off like this. And that's what a cubic actually really does look like. All right? So again, what I did is I cheated and I took the inverse of this one point that I found, and that's that inverted point all the way over here. And then if I drew the y equals x line, there would be that symmetry, just proven with that point that I chose. Okay, so good enough. You can escape if you don't know how to graph something by input-output, always. That implies that you know how to calculate numbers, and that's what needs to be done. Okay, one more of these. Yep, we're getting on. This is a lengthy set of notes, but it's a lot to set up with inverse. Heck, there's a heck of a lot of review going on. We're crossing so many different chapters here, things that you're expected to remember and know. Okay, alrighty. Input, say it. What do I input first? Please get this correct. 3, 2, 1, go. Ooh, not -3. Negative what? 1. You get the 0 on the inside. So -1 plus 1 is 0. Cube root of 0, 0. 2 minus 0, 2. So -1, comma 2. Am I red? No. -1, comma 2, right? I just wanted to make sure I got myself distracted there. All right, and it's a cube root, so I can plug in the next things. This is what should have happened. I asked for 3 points. So the 3 points that I want is -1. Fine, I'll put it over here. Do you see all the things toggling up there that I have nothing to do with? You look up at the top. And then I want to plug in 0 and -2. You want to plug right around those. This is the point of inflection. There are some things you have to know about a graph and before you input out. You can't just arbitrarily choose points all over the place. You don't get the shape that you need then. All right? 0 plus 1 is 1. Cube root of 1 is 1. 2 minus 1 is 1. So I got 0, comma 1, 0, 1, and then, you know what, I'm going to add one more point. -1 was 2, and then -2 plus 1 is -1. Cube root of -1 is -1. 2 minus -1 is 3. 2 minus -1 is 3. Not writing that down in this high-level math class. You know what I am going to do? I'm going to find the X Intercept. Finding the X Intercept, what would that be? So I want this to get 0. So it's 7. Why did I choose 7? What's 7 plus 1, everybody? 8. What's the cube root of 8? 3, 2, 1, go. 2. What's 2 minus 2? 0. So 7, comma 0 proves again that a cube root looks like this. Very, very smooth, and then, you know, very like, that's how it is. It just goes like it's very flattened, I guess is what you can say. Okay, so again, domain, all real numbers. I'm going to speed this up. It's always the case with cube roots. Same thing with range. Oh my gosh, this pen is just... Okay, and then it's the same thing for the inverse then. Switching x and y, these are exactly the same, so there's no change. I guess it slows me down for the note takers here, but I have to write infinity 3 times before it actually writes. So much fun. Okay, and then finding the inverse, f of x is y, now we make it x. 2 minus cube root of y. Okay, and then the whole idea of how to do order of operations. Anything that's outside of the cube root, move it. This is not division, this is subtraction. Okay, so it's x minus 2 equals the opposite of the cube root of y plus 1. No, you can't do anything with that plus 1 yet. It's stuck in a cube root. These are goofballs that are doing these things that I can't help you. But I am helping you to say stop it. All right? Divide by a negative. So I'm going to divide this by a negative and this by a negative. That's what division is. It's distributive. So that's another way of looking at it maybe in order to make sure you get that going on. So I have negative x plus 2, and that equals cube root of y plus 1. 2 more steps. Now cube. And we're going to graph this in May, something like this, a shifted cube root function thing. Maybe. We'll see. But it's not a big deal. Input, say it. And also, this came from an inverse of something. If you haven't gotten it yet, you could actually take those red points and invert them. You could switch those x's and y's, and then that's your new graph. And actually, I'm going to cheat and do that on one of the coordinates. Final answer, the inverse of f of x. You can see how my pen intermittently writes and doesn't write. Negative x plus 2 cubed minus 1. I've never graphed that before. Who cares? Input, say it. What do I plug in first for x? 3, 2, 1, go. Ooh, the negative in front scaring you? 2, because 2 becomes negative. Negative 2 plus 2 is 0. 0 cubed minus 1. So I plugged in 2, and I got negative 1. That's this point's symmetrical brother or sister. So therefore, if I plugged in 2, I'm going to plug in 1 and 3. 1, negative. Negative 1 plus 2 is 1. 1 cubed is 1. 1 minus 1 is 0. So I plugged in 1, and I got 0. Notice this is the symmetrical brother or sister of that point. 0, 1. And then 3 negative plus 2 is negative 1. Cubed is negative 1. Negative 1 minus 1 is negative 2. 3 negative 2. And then I'm going to cheat. This number is 7, 0. So the green graph should have 0, 7. And therefore, this graph looks like this. And you've seen your second cubic function in your life. That's what they kind of look like. They take off like that. Then I can draw the y equals x line and then go from there. So I do like the domain and range exchange, switch x and y thing for that last point. If 7, 0 is in the original, 0, 7 is in the new, and we can prove that. All right, I got 2 more things to do. One I'm going to write out. The other one I'm just going to shove at you as we have 8 minutes left. Sorry on a Friday ending up like this, but this is it. We're done. So then what we can do on, after I do this last concept is review. We actually have a lot of people that have to clean up their stuff from the first half of this chapter. The ability to simplify square roots and all that other stuff. The test really does, time-wise, track perfectly for Wednesday. Do we do that, though? Do we do tests on Wednesdays? Not necessarily. I might talk with the crew on Wednesday. Maybe we'll give you something on Wednesday, like a 2-part test or something. I don't know. We'll see. We'll see how it goes. We'll see what they say. But really, we're done. There's nothing new after this. Okay, do remember composition of functions. Hey, that was the only new thing from section 4.5. Here's another review concept. How to do an f of g of and a g of f of. Because here's what happens with their inverses, and here's the connection. If 2 functions are truly inverses of each other, then this will be true. You go through the composition of function thing. You do f of g of x, and you get not 1, not 0, not anything other than the letter x. I feel like Elmo, the letter x. Then, don't do anything yet. Go to g of f of x and do that calculation or that simplification. And you get the letter x. Then those 2 are actually inverses of each other. So there's a connection between inverses, 4.6, and 4.5, how to do a composition of functions. So I'll show you how this works, and when it doesn't work, what you're able to do. So here's the question. Boom. Are these 2 inverses of each other? I know there's a different way that you could probably do this. But if you don't do the composition of functions to prove this, you're gone on my test. Gonna get you. Okay, because I also want to see people doing the composition of function thing and see that they have that ability. Right, so you follow your directions. Wax on, say it. Backs off. You just do it sometimes. All right, and that's the point of that. I've been so curious. Why do I have to do this? I'm too cool. I'm not doing it. Well, good for you. You just got yourself a 0 on that question. Okay, so let's start this off as you're writing this down. Determine their inverses. Well, this is what Mr. Samuelis, and I think we'll word it perfectly too. Determine the inverses by finding f of g of x and g of f of x. We'll probably write that, and then that means you're stuck with having to do this way. All right, so here we go. G of x is x square root of x minus 5. So the next thing is name gets replaced with its functional value. Try to do the highlighting to help you out here because the highlighting is actually should help you out. And I was helping someone in Mr. Stronowski's Math 2 honors. She comes every day. I love her to death. She's like really trying to make it work, and really it is working out for her. So every single day in tutoring, that's why I yell at you guys. I actually got the tutor list now, who's going to tutoring, and there's only a couple people that I see that name on that list. So I know out of my 55 or 54 students in my Math 2 honors, like 2 people are using the tutoring room. 2, right? I'll have to look at that list again and see. So don't give me the business that you're doing everything you possibly can in order to do well in here. That's another kind of agitation with me as we move forward here. We're not doing what I said here. We're more likely to complain about our situation than do enough about it if we are struggling in the class. But that's what we see here. So the evidence is there that things need to change. We're only in October, so we got a long way to go together here. So wherever there's an X, what I was telling her was like, this is like a place marker. It's like an empty box. F of empty box equals empty box squared plus 5. And then it's waiting for you to put something different in there. So anyone that's struggling with that, maybe that can help your, mentally figure out why the very next thing I write is, now I went to the F function and I replaced the empty box with what it's telling me to replace it with, which is that square root of x plus 5. Or minus 5, sorry. I had that plus 5 over here written here. So that's why that turns into that. It's like a, replacement. Anyway, no, this is not square this and square this. This is a F, O, anyone? I, anyone? Foil, and feel free to do this. You want to save yourself some steps. Get rid of the squared and write it twice. It's the same thing. And then first, x, outer, inner, that's 2 negative 5 root x's. Again, we should be able to do this at this point. How many times we foiled in class in the notes. By the way, does this even remotely come equal to x when we're done? Yes or no? 3, 2, 1, yes or no? No. So it's done. I don't even care about the other part. These are not inverses because that first part did not end up equaling x. Now we do have 2 minutes left. And feel free to stare at this on the video because I'm still videoing right here. Here's a shoved in your face example of 2 that actually are inverses of each other. So as you pack up your stuff, I'm going to use my highlighting to verify that these 2 are equal. And then you understand as a student, this is what you're responsible for, this work. So as you're putting your stuff away, and again, if you wanted to watch this video, I'll be more than happy to, go through it. All right, so f of g of x. You replace, I need to erase that. You replace g of x with its functional value, and then you go to f and replace that x with that x cubed plus 1. So that's where the f goes from this step to this step. You went to the f function and did the replacement. Plus 1 minus 1 gone. Cube root of x cubed is x. Check baby, 1, 2, 3. There's check number 1. Now I need to do check number 2, and I'll use a different color for highlighting. G of f of x is this. So I replace the name g of x with its functional value. Then I go to the g function, and wherever there's an x, I'll replace it with this. The cube root of x minus 1. Cube plus 1. Freedom. X. They are inverses. Bell ring. Freedom. You get to leave.
On the homework,
Yes.
I did it by just like finding the inverse.